Great, thank you. So yeah, I'm here to talk about microservices and Docker at scale, why these are kind of the peanut butter and jelly of your modern application delivery. So what am I going to be talking about today? I'll be, going over a little bit about microservices, containers, what's cool about them. I know that this topic has already been part of some of the sessions, so it might be a little bit of the same information, but we'll just kind of have that intro. And then why are they mentioned in the same sentence most of the time? Why are they the PB&J for this architecture? Peanut butter and jelly go well together. We'll see a little bit why these two fit so well together. And then, what are the challenges that you might face in order to get good outcomes when you're working with containers and microservices? And especially some of the challenges that you might see at enterprise scale. When you go to larger scale, there are new challenges, or some of the challenges that you have, just get amplified. And, with scale, I'm not necessarily talking about thousands and thousands of microservices, deployment, all the time, but, just when you're getting into an enterprise where you have many applications, you have your legacy apps, you have new development that you're doing in microservices, and, making sure that you're able to support all of those. So I have, throughout, my work with Electric Cloud, I've worked on site with a lot of our customers who are going through this journey. I talk to a lot of people who are thinking about new ways to start doing their application delivery with microservices. So I'm getting to bring some of those challenges and lessons learned into this as well. But, with the caveat, I'm not, the expert on containers and microservices, but I'm going to bring some of my perspective and what I've learned. So I'm sure, there are folks here who will have other information or other perspectives as well. And, feel free to let me know. So what are microservices? They are a pattern for building distributed systems where you have, your suite of services rather than your one monolithic application. And each of those is running its own process, and each is exposing its APIs to then integrate and communicate with the other services. A main thing about them is, you want them to have some isolation where it's about doing one thing and doing it well. So you have they're independently developed and they're independently deployable. So you can have one team working on it, and the service has its own life cycle. And as I said, each service is focused on one part of that application where you break it down and doing that one thing well. And it's really taking one of those programming principles from Robert Martin that gather together those things that change for the same reason and separate the things that change for different reasons. So that feeds right into how you want to modularize your application even further and separate into microservices. Before going on, I'm just going to talk a little bit what I'm not going to talk about. So what I'm not going to spend time on or preach here is that I'm not going to say that microservices should be used for, they're by everyone for everything. I'm not going to force that down your throat. We, understand that it's not for every application, it's not for every environment or organization, and it's not kind of a one-size-fits-all panacea to all your problems. I worked with one of our customers who, there was a mandate from the top that, 2016, it's going to be microservices. That's how we're going to go. And it was pushed down into the organization. But then 6 months later, the whole thing was reversed as people understood that, this is not just something you push down without understanding all of the details of your architecture, how it would fit. So it's not always the right fit. And I'm not going to, bash you if you're not using containers or if it's not containerizable, but it is a cool technology, so we'll be talking some about that. It's solving microservices is not one simple line of Haskell. We're going to talk about some of the challenges, some of the ways, best practices to work around those. And finally, I'm not going to be talking about the different container platforms that are out there and comparing and contrasting them. There are a lot of ways to solve your problems. But some at a higher level, some of the best practices and that you want to bring into your pipeline as you're developing it. So now let's really get into it. Why microservices? From a DevOps perspective, which is the perspective I'm looking at things, speed to market is one of the most major focus points in DevOps, where the metrics that we focus on are efficiency, cycle time, time to recovery, and getting your quality software out as efficiently and effectively as possible. And microservices and then microservices based on containers really support this goal. They allow you to divide and conquer your complex distributed system. You split your application into the many services, and then you have that best practice of making sure they're as loosely coupled as possible, so you have that independence of development with each of your microservices. So in that way, since you have that independence, you have independent development, you have the freedom to then choose the tooling that's appropriate for that microservice, where you're not mandated to use the same set of tools across your entire application. You can choose what makes sense for your development. You can scale independently of other services. You don't have to worry about the state of the rest of the application. You can scale up your microservice or containers for that service. And then finally, you can have your own lifecycle, as I've said, where you're independent of other services. And then also, as part of that, have your own small autonomous teams that work on each microservice. So, this lets you scale both your service and your team as appropriate for your different pieces of your application. And then, as a part of this, resource utilization is definitely improved, where you have the services running on the type of hardware that is catered to doing that one thing well, and not worrying about, supporting the other pieces of your application on one big piece of hardware. So we said why microservices, now why containers? Containers, provide that well-defined, isolated runtime environment. It's focused on running one thing and running it well. So, the microservice is doing one thing, doing it well. The container is running one thing, running it well. So you can kind of see where those jive together. The nice thing is it acts as code. You just write your Docker file, and then you build your image, and save them in your repository, and you have your entire application along with the tool chain required for it saved in that one image. So you're actually, isolating the tool chain and dependencies for your application into that single container. And rather than having to package your application with, this big README file with the list of all of the steps that need to be taken to configure your environment, everything is part of that one image, and that, image is then pushed through your pipeline. So as part of that, you get much more confidence in environment consistency, which is so important as you're moving your application from dev, QA testing into production. Having that confidence that whatever I tested in QA, it's when I push to production, it's going to be not only the exact same application, but the process by which it was deployed, the tool chain, the way that the entire environment is configured is exactly the same way as well. So you have all of your libraries and dependencies in place as well. So, and then the per container overhead is so much less. You don't have your entire operating system that you have to ship or install for every single app service installation or deployment. So it definitely makes that footprint much less, and it makes for much better resource utilization, where you can share the underlying operating system, take any dependencies from there, and then build your own tool chain and application or service delivery on top of that. And then that that makes it even easier just to auto scale. Bring in monitoring and resilience with many of the container platforms that we have out there. So, we have a lot of those hosting services that helps you support auto scaling, and they provide monitoring services as well. A lot of them have orchestration involved in that. Most of them are focused just on orchestrating your containers, and so when you get into more into the enterprise where you have a combination of legacy monolithic components and microservices, sometimes you need to look for other solutions or other ways to do this as well. So why microservices in containers? We're going to take a little journey through time here, going back, to 2002, where we had one service per metal box. If you even had services and you were split up, this is of course a very poor utilization of resources. There's going to be, people who are conflicting over wanting those resources. If you're idle, you move a little further down the timeline and you get into virtualization where you have VMs, but you might be running multiple services on a VM, and that really contradicts the whole isolation of your service, making sure that you have your tool chain and your resources for your service. So you might have conflicts with dependencies, dependent libraries. You might have one service taking up all of your resources, and ultimately you'll likely find out that certain services, when you get to production, have to be deployed independently anyway. So we get further down more recently where people start deploying their services to an individual VM for each service, but then that's giving you the isolation you need of your network isolation, all of the resources, but again you have the overhead of the operating system. So to today, for the past few years, containers have been getting a lot of traction, and there's a lot of reason for this. You have that really good mesh of where your application architecture is going with microservices, and then being able to provide that isolation of resources in a container, and the ease of starting it up without taking the overhead of the operating system. So that's really, kind of the peanut butter and jelly part where you make your sandwich. Microservices are about one process that solves a single problem. Containers are, run a process and its associated dependencies with minimum overhead. So a microservice, as I've said, is about doing one thing, doing it well. Container is about running one thing and running it well. So it just kind of feeds one into the other. And then because they work so well together, there's also an overlap in some of the challenges and best practices as well. So with that, let me jump into challenges. So, some challenges that are common to both. These are complex tools for solving complex problems. I mean, yeah, you can start with a single Docker file where you're kicking off like an Nginx HTML page, and definitely it's something to try to see how cool it is, but this isn't the problem we're trying to solve. You're splitting up your application into microservices model, and running it on Docker is complex. It isn't necessarily easier to do than your monolithic application. There are a lot of reasons why monolithic applications are easier to maintain. But in the long run, if you understand the benefits of moving to a microservices architecture, then you want to also understand the tools and the process and the skill set that's required to get there. So understand that it's a journey and there is a lot involved. It also introduces complexity to how you're orchestrating your software delivery. For your monolithic application, you might have had a single CI process feeding into your delivery pipeline. Now you're breaking your application into 30 microservices. The best practice is to then have 30 delivery pipelines, that are running for each one that can run independently, and maybe they'll all converge into an integration pipeline, depending on how you'll be taking that forward. But the real practice is to be able to deploy each one individually with its own separate delivery cycle. So, and then that also, then means you have those 30 pipelines that you're managing, 30 pipelines that you're monitoring. That adds more for you to understand and architect into your solution. Testing also becomes more complex. You're testing the individual services as you develop them, but also, as you progress through the pipeline, You need to introduce integration testing to be confident that your service works well with the other services, all of the communication and calls into other services are working properly. So you need to employ the appropriate strategies to do that. For deployment itself, some parts of it does become easier if you're doing, with a Docker container, the deployment is simplified. If you're using one of these container platforms, scaling, monitoring, and resiliency becomes a little easier as well. But again, you have that scale of the number of deployments that you're orchestrating and managing. And then, what about logging? You may be writing logs in your container file system, and then you delete the container. Then, of course, your logs wouldn't persist. So understanding how you want to manage your data, if you want to go back and audit that later, it's going to be a problem. And then, finally, I think, especially for people who are in the enterprise with those legacy applications, how do you update applications that are in a hybrid state? Not everyone is going to be starting with greenfield applications where they're able to start with microservices. You might have existing legacy components and then built microservices around them to provide new functionalities. So how do you coordinate that deployment and testing of your entire pipeline for the hybrid application? All right, so microservices themselves, I'm going to go through a lot of challenges and then hopefully get to some best practices too. So microservices themselves can be challenging. Distributed systems are hard. Service composition can be tricky, and it can be expensive to change. It can be especially expensive if you've already started going down the path and then you realize that you need to make changes, and trying to backtrack and make changes is even harder. So, understand that when you're starting that journey, to make sure you know where you're going. Once you have microservices, then you have inter-process failures to start taking into consideration. What used to be a method call where you just get an error message returned is now a call over the wire where you're dealing with other machines, you're dealing with load balancers, and any other issues that might come with communication over the network. So you have to understand those and have the appropriate failure handling in place for that as well. Abstractions, they look good on paper, but beware of bottlenecks. You could introduce huge latencies that you don't expect. You previously had direct interactions with these different processes. Now, by introducing an abstraction layer, what is the delay or latency that you're adding? Think about it before you create it. How many times am I going to make this call? If I'm making the call once a day, it's not really going to make a difference. If it's hundreds of times per second, should this be an abstraction layer? Is that the right path to take? So taking those things into consideration and understanding that abstractions are very powerful, but they can also introduce a lot of delays and bottlenecks. And then, aside from the technology, what about the people? How are you going to organize your teams around your microservices? Are you planning to, have one team per service? Do you have enough people in your organization to have one team per service? And if you do go down that down that road, is your organization the kind that would go, quickly go from one team per service to one silo per service, where it's like, oh, well, that happened with their service, it's not my problem, throw it over the wall, instead of coming together and working to solve the problems for, the whole organization's application. And then how does Conway's Law play into this? Is the way that you architect or organize your teams going to dictate your microservices, how they're architected? If you have 4 teams, does that equal 4 microservices? So understand, both sides of that as you're going forward. How many microservices do I want? What kind of team structure is going to play into that, and how will it affect the way that my implementation or architecture comes out of it? So, again, good system comprehension is key. You want your architects to have a really good understanding of your entire system, understanding, all of the services, all of the integration and interaction points between them. Because if you don't have a good understanding, how are you going to, optimize or iterate on that architecture going forward? So making sure you have that team or group of people who have that understanding, and having it across the different teams where you don't have that split between development and operations, understanding how the development process works versus how things are pushed into your environments. So some more challenges. This first one here is from a tweet from the Honest Status page, where after they brought in microservices, every outage is like a murder mystery. Which microservice failed, or which one failed first? You might have a cascading problem. How do you backtrack the path of all of the communication to find where the issue originated? You need to have the right monitoring and logging strategies in place to make sure you can do that, where you're not just looking at this huge list of or pages of different log files trying to figure out what happened, where did this actually start. Dependency management becomes key, where maybe you revved your API for service A, but then service B is dependent on your old deprecated version. Making sure that you understand that and have a strategy in place. Are you going to maintain both APIs? Are you going to make them backwards compatible? What is your strategy there? And then there's the added complexity of getting your entire application started. It's not just the ease of the monolith where you're deploying one WAR file and the whole application is up. You have these 30, 50 microservices that all need to be deployed. So if you really want to be testing your services properly, if you want to test service A, does that mean that your 25 other microservices also have to be deployed in your environment to complete that testing? As part of that, automation becomes really key to making sure you can do the types of coordination and testing that's required. Correlation and tracking is important. Going back to that murder mystery, your first service processes the request and then you get an error down the line, making sure you can go back and correlate where did it start. So I've talked about microservices and their challenges. Let's talk a little bit about containers. You need to be able to manage the state, the volume, have the data management, understand where you will need your data, how should it persist. Of course, as I mentioned, if you have your log files get deleted with your container, that's going to be a big problem when your auditors come by 2 months down the line and want to look back. So making sure you're understanding what are you using for your data storage and how will it persist. Security is another consideration. People consider containers to be a black box in many cases because it's just an image that you run Docker run on, and you may not be how are you going to scan it? How are you going to make sure it has everything required? How are you going to check down the line that there hasn't been any changes to that artifact as you're pushing it forward? So having a process in place to certify each image as it goes through. Monitoring is also an issue. Containers are expected to be transient in nature. So, and many monitoring tools are not designed for that, where you bring up your container, you tell your monitoring system about it, and it's going to be monitoring that into eternity unless you tell it to stop when you delete your container. You don't want to be in a situation when you're going to your monitoring dashboard and it's just full of red squares looking at containers that are long gone, and then having to then go back and figure out, clean all of that up. So you want to build this into your process, build it into your pipeline where you're triggering, enabling and disabling monitoring as part of your automation, or using tools that are more container aware or more able to work with this more dynamic environment that you're using. And then, what hosting service should I use? There are so many cloud or container platforms out there, and it keeps growing. There's a lot of development, a lot of innovation in the space. Is it something you want to decide today and lock yourself into? Do you want to be able to change later? So do you want to architect, your overall pipeline to be able to have that flexibility of changing your platform as you move forward based on your needs and requirements? And then, as with VMs, we also have to consider container sprawl. It doesn't solve this problem. Oh, I have a lot to cover, so it's a good thing we have a little bit of extra time. So challenges at enterprise scale. So when you get into then in the enterprise and that scale, there are different challenges that get introduced. It's only magnified. I've worked with a number of our customers who work at, ridiculous scales, and the things that they have to think about really, you have to think about things at a very different level and a different perspective a lot of the time. One thing from an enterprise is just the technology maturity. A lot of the time enterprises are looking for technologies that are proven and mature. This is changing, but where people are getting more adventurous, but it can be harder then to introduce these new technology, new ways of doing things into an enterprise that is established and has been used to doing the same thing the same way. Forrester did a study in 2015 where they were looking at the three main, the main challenges for containers as seen by enterprises. Security is definitely one. Variability in performance. This is one I've seen firsthand where I worked with one of our customers who was, kicking off 100,000 processes a day. And then, any variability in, just the start of running an automation had a cascading effect through their entire process. So this is not something that, someone who's running 5 jobs a day is even going to think about. But when you have to have that throughput through your system that is consistent and, you have to count on it to get all of your work done in that day, you start looking at the most minute pieces, breaking it down as far as you can and understanding the effects of any change. Integration to existing tools and processes. This is important, and in enterprises, there may already be investment in a given tool set. In large enterprises with a lot of teams, you might have the different teams choosing their own tools. And it's hard to mandate across an entire organization to change your tool to, tool set to this. I've worked with an organization that tried to do this and failed. People resist, it's not easy. What you want to do is try to work with their tools, find ways to orchestrate what they're already doing and bring in, new technologies as part of that as well. And then when you have one of everything, governance and auditing becomes more tricky. Again, in enterprise, you're going to see that bimodal or multimodal delivery where you have part monolith, part microservices, and everything in between. So you want your orchestration to provide that central pane of glass where you can see everything that's happening, be able to come into one place and get that view across all of your applications, regardless of how they're architected. So last year, we worked with a large Fortune 20 bank that had 6,000 applications that they were looking for our help to, automate releases and pipelines. They did like containers and were motivated by, the efficiencies, scaling and replicating, ease of replicating that containers bring. But, realistically, when they went back and looked at their applications, only about 20% actually fit into being containerized. So, that's something you definitely want to do is take that time to understand without having some push from above. So for them, it's not a huge overhaul project of rewriting 6,000 applications, which, that would be honestly ridiculous. So it's instead making the changes, with new development, where it will be done with a container-friendly approach. So I will jump into best practices. I think I'm going a little over, but hopefully it's okay. I think we have a little buffer. So common best practices, your automated software pipeline is your friend. That's something we definitely believe. Ideally you have one platform that handles all of your software delivery. Test coverage is important. Do you have the right balance of unit, microservice, and then integration end-to-end testing? And then are those tests automated? Automation doesn't just mean being able to run a script and kicking off tests. You want them to be really automated, where they're part of your overall automated pipeline, where you run your your CI check-in will kick off your build, that will then provision the environments required, run your test suites, gather those results, and then drive the rest of your pipeline based on those results. Have the confidence that your testing is thorough, where you can automatically then promote your pipeline on into the next environment based on those testing results. Test automation is really key. If you don't have your tests automated, it's, I think, more important to step back and look at that problem before you look at moving into microservices, or minimally look at doing both things at the same time, because without automated testing, you're not going to be able to solve these problems well. Self-service automation is really a best practice that we like to recommend, where you're getting rid of your ticketing system. You're not dependent on a person to give you the hardware with the configuration that you need. Why do you want to have that wait time? I worked with a customer a few years ago where I implemented just this, where they were able to automatically self-service provision and configure their testing environment at the push of a button. And it actually brought the time down for getting that testing environment for their developer or QA engineer. From when they were using the ticketing system, it took 1 month for the person to come back with the environment for them. Once we automated this, it was 10 minutes. So it's huge. It really empowers your developers to drive their own cycles and work as they need to. Chat ops is also pretty cool. We have customers who are doing this, where they're it helps reduce the onboarding time. People can just scroll up and look at what other people ran. Definitely something to look into bringing in. So consistent logging and monitoring is important. For monitoring, you don't want to just monitor the overall system your containers are running on. Looking at that CPU isn't necessarily going to tell you about the health of your container. You want to look at monitoring tools that can get you that granularity into the container. You also want logging systems that can, and monitoring systems that can use techniques like correlation IDs, where you add a unique GUID to your header or somewhere in your initial log when a service is received, and then that ID is maintained with that throughout each of the services that is touched while it's being served. So then you have monitoring tools where you can aggregate that data and look at all of the calls, and then you don't have the problem where you don't know how to solve the murder mystery. All of that information is right in front of you. All right, so microservices best practices. I've talked about this, understanding the domain before you make decisions, like where you're going to break your application apart. The approach that we really recommend if you're in a greenfield application is to keep it modular to start with, but don't initially start with microservices. Keep it as a monolithic application, but with your end goal of microservices in mind. Modularize it. Really get to understand how the domain and the API boundaries, and then introduce, the network socket, that part of it. So, solidify your application or architecture, and then split it along the seams that you've already been creating throughout your development. Be rigorous in your failure handling. In our monolithic models, we're used to getting a response for, I keep on hitting that, for your call right away. with an error. But when you have these calls going over the network, there are a whole slew of different types of errors you might be getting. So taking those into consideration in your error handling, what if a call hangs? What if it gets lost somewhere? Being able to handle all of those different scenarios. And then be flexible in staffing your organization. We talked about, Conway's law, understanding that your organizational structure is likely going to impact the way that your microservices are made. So have that in mind as you both architect your microservices, but also decide your organizational structure as well. And an ideal case is to have small autonomous teams that drive the entire delivery of one microservice from end to end. But that's not always possible. Everybody doesn't have that many people. But so just be ready to be flexible and learn and be able to adapt your organization as needed. I think I've talked about this, having that independent delivery pipeline for each service. The big value of microservices is that they're independently developed and released. So you want to separate the delivery pipeline. You want to be able to then test each service independently. As part of that testing, take advantage of different testing techniques like test data management, where you're creating test data to cover all of your corner cases. And then also techniques like service virtualization, where you're stubbing out the interactions with the other services, so you don't have dependence on having all of your services up in order to do testing of your one microservice. So you just stub out those interactions, and then you can do most of your testing for the different calls without having to have like that orchestration coordinated deployment of 30, 50 microservices. And then pay attention to where your data is stored, so that you understand the persistence and how you're going to use that data later. So containers, best practices. I'll go through this somewhat quickly. I know I'm over. All right. So use an enterprise container registry. Use container native monitoring tools where possible. You don't want to just see the health of your entire, the overall system CPU. You want to look at specifically at your containers. Think about where your data is stored and how it will persist. Use the right type of storage. On the security side, pay more attention than you would normally. Use tools that are available for scanning and signing your images, so you can validate them as they're going through your pipeline, and you have that confidence in the fidelity of your environment and your process. And do vulnerability tests and use those best practices. Use tools like Twistlock for doing things like that. And then introduce access controls, so not everyone is accessing the container as root. Make sure you're putting those authorization and privileges in place. And then, as I've said before, make sure all of these pieces are automated as part of your pipeline. You don't want, when you start expanding and having so many processes running, you don't want to be in there running things manually. Everything should be automated, where you have that centralized place where you can see where you are in your process. So, be able to track what is running where and why, using the right container platform or architecture. Avoid image bloat. You don't want, you want to keep your containers tight and light. Think about working with immutable images, where you throw away the SSH key. If you need to make any change to that environment, it's a change back in the definition of your image, and you run the whole deployment again. No one is logging in and making changes manually to bring in that vulnerability or changes that you're not tracking. So I think that is it. This is just a fun image to end on. Make sure your load balance, you don't want all your containers falling off the boat. So I apologize for going over time, but thank you very much.
So we have a couple minutes for questions. I can come around with the microphone to make sure you get recorded on the video.
Hello. In our organization, we're using Docker orchestration, and it seems people got the Docker fever now, and they want to Dockerize everything. So we run our pipeline in Jenkins, and Jenkins, we built the applications using Maven. Now people are Dockerizing the execution of Maven inside Jenkins, and we have a Jenkins cluster, and as we speak, there are people down there Dockerizing Jenkins itself.
Yeah.
So my question is, one of your slides you said, the banks realize that only 20% of their applications are Dockerizable. So how can you tell whether an application is more suitable for Docker or not?
Sure. And I understand that, Docker fever and everyone wanting to put everything in a container. A lot of it has to do with, the APIs, the integrations that are required with other, communication that's required. Is it really tightly coupled with other processes, and then the dependencies that you might have in place. Maybe we can take a little bit more offline to go a little bit in more detail, but yeah, I understand the challenge for sure.
Part of ours, part of ours is
Actually, let's just you can hold that. You guys can chat on it. Yeah, sure. Any other questions?
Hello. So did you deploy microservices on cloud, or was it all within an internal network? And what security aspects around containerization you guys had to consider?
So we work with customers who are doing both. There are people, and it depends on their regulations that they have in place. When we're working in, as I said, the banking industry, where there are a lot more regulations and auditability, that was one of the considerations for where and how things are being deployed, and putting a lot of those vulnerability tests in place using tools like some of our customers use Twistlock to understand those vulnerabilities. So it depends on what your regulations are. We do have people who are using cloud and comfortable with it, but we've seen both sides of it, where there's because of the way that the enterprise what concerns they have in place and what rules and restrictions they have to do it on-prem.
Actually, I think we're all done for the questions on this one. Let's give her another round of applause here.